Welcome. In this video, we are going to look at multiplying polynomials. So it's going to be very important that we remember our exponent rules when you're multiplying powers with the same base. So just a reminder, if you have x squared times x to the third, that means x times x times x times x times x. So we end up with x to the fifth, or we can just add those exponents to get where we are going, because it's looking at how many factors of each base do we have. Okay. When we're multiplying, sometimes it can seem like these parentheses are doing something different, but when this is multiplying a monomial times a monomial, this means the same thing as 6 times y cubed times 3 times y to the fifth. That's all multiplication, which means we can multiply the things we can multiply. So we can combine 6 times 3 because multiplication is commutative. So 6 times 3 is 18. And then y to the third times y to the fifth, right? This is 3 factors of y times 5 factors of y. We end up with 8 factors of y. So we're just multiplying, combining the things that we can. So any monomial times monomial, those parentheses aren't doing anything. We can multiply the things we can. So 3 times 9 is 27. M, that's one factor of m. N to the second, that's 3 total factors of m. N squared, that's 2, plus another 3 total factors of n. Hey, same thing goes if we have multiple monomials. There's lots of things going on here, but we're just going to multiply the things that we can. So a quarter of negative 12, right? This is all multiplication. If it helps you, write it out as I'm going to leave those parentheses around the negative 12 so you can really see that we're still multiplying, not subtracting there. Multiply the things you can. A quarter of negative 12 is 3 negative because it's a negative times a positive. How many factors of s do we have? 1, 2, 3, 4. So s to the fourth. How many factors of t? There's 2, 3, 4, 5. So t to the fifth. Combining the things we can combine as we are multiplying. Okay, so those are all monomials times monomials. We're just multiplying monomials together. If we have a monomial or polynomial times another polynomial, we need to make sure we're multiplying everything to everything. So we're going to be using our distributive property that we can distribute multiplication over addition and subtraction, as long as we take this thing we're multiplying and multiply it to every term inside that polynomial. So if I take 4 times 3x squared, again, we're just multiplying the things we can. So 4 times 3 is 12, and they're still x squareds. 4 times 4 is 16, still x's, and 4 times negative 8, 4 times 8 is 32. So we get negative 32. Multiply everything times everything using that distribution. Okay, this next one looks a little different, but it's the same thing. We have this monomial, 6pq, and we're multiplying it by this binomial. So we're going to multiply that by both terms. So if I take 6pq times 2p, coefficient times coefficient, 12. Okay, how many factors of p? 1, 2. So that's p to the second, and just q. Minus 6. How many factors of p? Just 1. And how many factors of q? Q times q. Get q squared. So we're just doing that same multiplication with our monomials, but distributing it to multiple. That's multiple multiplication problems. If you need to write it out, it's 6pq times 2p minus 6pq times q. Right? That's what we're really doing there. Okay, next one looks a little messy. We're going to take this monomial and multiply it by the binomial. So we really have two multiplication problems there. A half of 6 is 3. We have 1, 2, 3 factors of x, so x cubed, and 1, 2 factors of y, y squared. Take that same monomial times the next term, and we get half of 8 is 4. 1, 2, 3, 4 factors of x, and 1, 2, 3 factors of y. So we're still using those same multiplication properties using that distributive property. Okay, so monomial times monomial, monomial times polynomial, we're doing very much the same thing, making sure we distribute. Gets a little bit more complicated when we're multiplying binomials, but we're still using the same distributive property. So we're going to take each term in our first binomial and multiply it by each term in our second binomial. So we're just distributing everything to everything. So I'm going to focus on this x first. I'm going to take x times x. X times x is x squared, and then x times 4 is 4x. All right, once we've distributed that term to every term in my other polynomial, I'm going to focus on the next term. 3 times x is 3x. I'm going to add my like terms together, so I'm just going to throw that right with my x's there. And 3 times 4 is 12. Hey, you could write that in one big long line, but our next step is going to be combine like terms. So I had already just identified when I was multiplying that those are like terms, so I can add them together and say 7x plus 12. All right, so we multiplied x times x to get x squared, x times 4 to get 4x, 3 times x to get 3x, and then 3 times 4 to get 12. So we ended up with 4 multiplication problems there, taking each term in our first polynomial times each term in our second polynomial. Okay, so let's do the same thing here with this next one. We're going to take my first term and multiply it by both terms in my second polynomial. A times a is a squared. A times -4 is -4a. Then take your second term and multiply it by all of your terms. So again, we're going to have 3a like terms, so I'm just going to put them right here underneath. And then 3 times -4 is -12. So we get a squared minus a minus 12. Nice little quadratic trinomial there. Okay, this next one looks a little different, but really it's the same thing, because what does it mean to square something? It means take that thing times itself. So if you have a binomial squared, you're really multiplying a binomial times a binomial. We're going to do the same thing. Grab your first term, multiply it by both terms. Grab your second term, make sure you bring that negative with you. -4 times x is -4x. -4 times -4 is positive 16. We end up with x squared minus 8x plus 16. Okay, so be really careful with that squared term. It's really tempting to distribute that exponent over addition and subtraction. Those operations are not directly related to each other, so you can't skip from one to the other, right? We have that multiplication that's in between addition and exponents, so write it out as two binomials multiplied by each other. Okay, different terms here, but we're still doing the same thing. Grab your first term, multiply it by both terms there, making sure you keep the negative with your 3t. So 8 times 1, 1, 2, 3, 4 factors of r squared. So we get 8r to the 4th minus 8 times 3 is 24 r squared t, right? Those aren't common, those don't have like basis, so we can't combine those. That's totally fine. R squared t's are okay to have. Take your second term, -t times r squared. Ooh, t r squared t, those are like terms. So I'm going to put that right underneath here and make it r squared t. And then -t times -3t is positive 3t squared, right? 1, 2 factors of t, -1 times -3, positive. So here we end up with 8r to the 4th minus 25, right? That's 1, r squared t plus 3t squared. Okay, last two here, we're going to complicate things a little more, but really we're doing the same thing, it's just more multiplication problems. So here we have a binomial times a trinomial. We're still distributing everything to everything. We just have more multiplication to do. So take one term and distribute it to all of your other terms. X times x squared, there's 1, 2, 3 factors of x. X times 4x, 1, 2 factors of x. X times -6, -6x. Do the same thing with your next term. Make sure you bring the negative with you. Oh, those are like terms. -5x squared minus 20x plus 30. Combine your likes terms. We get x cubed minus x squared minus 26x plus 30. And that's all it is. So we're still doing the same thing. It just ended up being a few more multiplication problems because we had more terms. Okay, this one here, options, you can distribute either way. So if you like doing the 2 to the 3, do it that way, but you could also grab these 3 terms and go the other way. So if that's more comfortable for you, that's totally fine. So -4 times 2 is -8, 2, 3 factors of x, x cubed, plus 20x squared. Okay, then take your next term, do the same thing. Okay, -10, -20x squareds plus, oh, that's not right, 50x, right, -10 times -5. Okay, then grab your last term, do the same thing again. We're just distributing everything to everything. 3 times 2 is 6, and those are x's, minus 15. Okay, combine your like terms. I already lined them up. Ooh, what is 20x squared minus 20x squared? It's like saying I have $20 and I bought something for $20. Now I have no dollars, nothing. Okay, so I have -8x cubed plus 56x minus 15. Combining those like terms. So distributive property, we're just multiplying through everything, whether it's a monomial, a binomial, a trinomial, a polynomial with 17 terms. Just make sure you multiply every term in one polynomial times every term in the other polynomial. Okay, that is all I have for this video. Thanks so much for watching.